So I have never been very happy with the QA403 standard software. And what I did was I went and Juiced Breed did this wonderful application to do things like THD versus frequency charts like this. And I took his code from GitHub, modified it a little bit, and converted it into Windows Presentation Foundation. A long story short, I created my own spectrum analysis so that I don't have to use the rather gnarly default QA403 application, which, looks kind of like this. The difference is that it's very hard to find things here. Like, where's the generator? Well, it's not here. Oh, there it is. And what is it set to? Well, I don't know. How about if nope. Oh, there we go. Except this doesn't do anything because it's not actually turned on yet. I have to turn it on. And of course, if I do this while it's running, yuck. So that's just one example. Plus, there's no way to change this without knowing that I can right click here and enter free. Anyway, so I thought I would try to make something much more suited to what I normally do. And this, for example, here, let's watch this. I'm just simply going to do 100 millivolts output, a frequency plot. Start at 20, go to 20 kilohertz, 2 steps per octave, only test the right channel and or left channel and start. Down here we get a little view of what's happening. And again, this is all Juiced Breed's code pretty much, with me just changing the user interface other than this spectrum, which is more my code. All right, as you can see, this runs just fine, and it's a very typical kind of a plot. Here I'm looking at in percent. I can look at it instead as dB. But, all right, set it to 6, turn this stuff off. 96 kilohertz, 64K is fine. Let's just go ahead and start it. We'll see it run. There we go. All right, and it's flat, there's no signal. Even though the generator has settings, I made it so I can just turn it on and off with a little click. So there's the signal, and at 6 we see a pretty nice noise floor on here. I'm running on a very long cable near some power so I can get some hum and distortion components that are visible, especially actually as it turns out on the right channel. But let's take a look at the left channel for a sec. All right, yeah, there's very little distortion coming through here, but if I want to see it exactly, I can just turn that on and I get my harmonic distortion markers. If I look at the right channel instead, we'll notice there's noticeably more distortion, and up here we get a summary of it. We can also turn on the power markers because there's these 60 hertz hum components, and this will go through 50 and 60 hertz harmonics and find any that are relevant and put a little dot on them and show them up here. So I haven't had to do anything, and it's already answering most of my questions. And finally, I can bring up the summary data chart and get all of the relevant data associated with this without having to do any work at all. Now, if you look at the numbers closely, my noise arithmetic is wrong. I haven't completed that yet. But in terms of user interface, this is a very good demo of the way it works. And these are nice charts. So I can like scroll the mouse wheel, change the chart here, change the chart here. I can change the range here or the frequency range. Again, I can zoom in if I want. So very easy to use and way happier with this than where things were.